I'm Duncan McLeod, and this is the TechCentral podcast brought to you today by Dell Technologies. I'm pleased now to welcome Tony Bartlett to the podcast. Tony is Director of Data Center Compute at Dell Technologies South Africa. And we're going to be chatting about cloud computing, edge computing, and everything in between those two, I suspect. Tony, welcome to the podcast, and thanks so much for your time.
Thanks, Duncan. Thank you very much for the opportunity to chat with yourself and the listeners.
So, Tony, let's start with the basics. What exactly is edge computing, and why is everyone talking about it all of a sudden?
So I guess a formal definition would be that it's a distributed computing paradigm that essentially just brings the compute and the data center storage closer to where it's needed. I guess it's to improve response times and to save bandwidth. But I suppose in a nutshell, the simplest way to put it would be that it's really to just bring the compute back to where the real world and where everything is happening. If we consider that about 10 years ago, there was a massive shift, or possibly a little bit longer than 10 years ago, a shift to move everything from the edge, where you had mail servers and that type of thing, in factories under desks, and all of that was moved to a central location. And that was to improve operational efficiencies and better to support those applications. But about 3 years ago, things started to change, and people realized that IT wasn't just about managing those applications, but it was about, I suppose, digitally transforming your business. And effectively, the data doesn't reside in the data center. The data has been created at the edge, in the factories, in your shops, in your retail outlets. And I guess it's all about making sure that IT then goes and follows where the data is. And the reality is that business activity doesn't really happen in the data center. The business activities happen on the edge, and hence this shift back to the edge.
It seems to me, Tony, that the industry has been talking about this stuff for the good best part of 50 or 60 years now. We started with the mainframe era of computing, where everything was centralized and we had dumb terminals. Then we had the era of Microsoft and Intel, where we had client-server computing, where we had fat clients on the desktop and a lot of processing was done on the desktop rather than the data center. And it seems we shifted back towards the mainframe sort of model in the last decade or so, particularly with the advent of cloud computing and devices at the edge, perhaps, but not necessarily always getting a bit dumber again. Are we ever going to get out of this cycle? Is it always the centralization, decentralization, centralization, decentralization curve that we are going to follow for decades to come? Tony, what's your view on this?
Honestly, I think it is going to continue. There's always going to be this shift, and either towards the edge and back again. But each of those shifts doesn't result back to exactly where it was before. Effectively, the way I see it is that there's still going to be a continued requirement for whatever's in the data center at the moment, whatever's in the cloud, whatever's in your primary data center. That's still going to continue. Effectively, though, is that if we look at where the biggest growth is for the next period, it's going to be on the edge. So it's going to be a combination of both. And effectively, all you're going to do is you get this pendulum switching backwards and forwards, but it settles somewhere in between. Ultimately, it's never going to be exactly like it was before.
Yeah, and it's a different set of things driving it this time around, right? I mean, what are some of the industries, and what are some of the applications that are being used in those industries that is driving the edge use case once again?
So, Duncan, there's no particular industry or vertical at all that's driving it, on its own. I don't think there's a single industry that's not immune to having this need to generate this compute and manage this infrastructure at the edge, whether it be a manufacturing facility, whether you take a mine, whether you take farming, retail, even the telcos. There's absolutely no industry that's immune to it, and all of them are going to benefit from having this compute closer to the edge. There's something called, we term it as data gravity. Effectively, it's actually, data is actually drawing the compute closer to where it is. And it's just that, IT is not immune to the laws of physics. The laws of physics don't allow data to be transmitted faster than the speed of light. And then we've also got the laws of economics, the fact that there's just no ways that you can have a situation where you can spend infinite amounts of cash on providing bandwidth and providing network links to support everything being in a central location. So once you've been governed by those laws, there's a necessity to have both of those situations arising.
Yeah.
And companies, all of those industries will benefit from it.
We've obviously seen a lot of investment in recent years going into hyperscale data centers, a bit of industry jargon, which basically means very large data centers. Do you think that there's going to be a bit of a shift in the pendulum back, or do you think both are going to coexist and there's going to be demand going forward for these hyperscale data centers, and the sort of investment we're seeing being made into them makes sense?
No, absolutely. Both are going to exist and coexist. Effectively, we see the edge as an extension of your cloud. We don't see the cloud as necessarily one of the hyperscalers. Absolutely, the hyperscalers is one form of cloud, but there's absolutely no difference between having your cloud operating models in your own data center or a hosted data center. It's all about the operating model that you're supporting as opposed to a physical location. But obviously, there's huge benefits to customers to have the centralized approach in a public cloud operator for many reasons. But the reality is both are going to coexist. And if you continue to have those operating models replicated at the edge, effectively the edge becomes an extension of your cloud operating model.
Right. And it's become seamless to
yeah, but if you look at your question around the costs and where the growth area is, if we had to consider that the amount of data growth that's actually happening on the edge at the moment probably accounts for about 10% of all the data that's being generated, whereas the expectation is by about 2025 that will be closer to 70 to 75% of all data being generated. So that's a significant increase. So if you look at where the growth areas are, not to say that the data centers or the hyperscalers are not going to shrink, they're not going to decline, but perhaps the biggest growth area is actually going to be on the edge.
On the edge, yeah. And I imagine there's some mission critical applications on the edge as well. I mean, we're heading into the era now of autonomous cars, self-driving cars, powered by 5G network infrastructure. And I'm imagining that in the case of vehicles having to make decisions on the fly that can affect people's lives, you need that processing to be taking place on the edge because of the low latencies involved. You don't want to have to send vehicle driving information back to a central data center to process it and then send it all the way back to the vehicle, because that's going to take too long, right?
Well, that's exactly it. I mean, if you were to look at some of the use cases where the edge is absolutely critical and relevant is number one, like you pointed out, the fact that there's going to be requirements for activity or for results or output to be generated in real time. Where latency, you cannot wait. I mean, your example of the autonomous cars is great. If there's an incident on the road and someone cuts in front of the autonomous car, there's no ways you can send those sensor data off to the core, into the cloud, or wherever you're doing that, and then having to wait for a result before it takes some remedial action. It's got to happen immediately. Now, autonomous cars is maybe a couple of years off still in terms of being everyday kind of thing, but in the real world right now, that same requirement is there. If you take a factory, for instance, a manufacturing facility, you've got the situation where you've got sensors, whether it's for measuring vibrations or other telemetry type information about heat, video details around, if there's anything on the production line that could potentially cause some form of damage or whatever. You cannot wait to stop your production to remediate some event by sending it to a centralized data center. It has to happen in real time. But the second element outside of the real-time component of why mission-critical workloads are running at the edge is also just, as I mentioned, the economic side of things. If you consider that even with 5G, starting to become more mainstream, there's still a cost associated with it. And when I was talking about those increases in data of what's happening on the edge, those 5, 6, 7 times or fold increases of data, there's still a finite amount of data that can be transmitted. So you've got to make a call of, do you process everything in the centralized data center at a huge expense from a network connectivity and latency perspective, or do you bring it back to the edge. So you've got to have a balancing act around what makes sense for each individual workload.
And you need to know what data is important to you, because you can generate a huge amount of information, I'm sure, at the edge, and not scrutinizing that data for the insight that you need means you're just going to end up with a lot of junk data.
Well, that's it. I mean, most of the data that's being generated at the edge is either video type data or telemetry type data, machine data generated by machines. And it's just impossible to sift through that, and you need specialized equipment on the edge to actually support and manage that as well.
How do you draw a balance between the two? How do you decide what you're going to do in a hyperscale data center environment? How do you decide what you're going to do at the edge? Is it use by use cases you decide on each example as you deploy?
It's absolutely understanding your actual workload itself. Understand the amount of data, the type of data that's being generated, understand what kind of outputs you require. We've mentioned the fact that it's around whether it needs to be delivered or the results need to be delivered in real time. If that's the case, then it's absolutely suited to the edge. And also, if it's just going to exceed those cost thresholds to actually transmit it to be centralized, processed in a centralized manner. I guess those are the two major things that you need to consider.
Yeah.
But it's really about understanding your actual workload, assessing it, and then placing it in the most appropriate place.
So what does this mean at the end of the day for companies' CapEx and OpEx costs, especially if we're looking at more and more data being processed at the edge in the coming years? What does it mean in terms of capital investment, and what does it mean for operational expenditure going forward?
Duncan, I don't actually think it really is material in the sense of whether it's a CapEx or OpEx. In traditional IT, one always saw an IT expense on premise, whether it be on the edge or even in your own compute room. That would be considered always a CapEx expense. But things have evolved in the last number of years, and you can actually provide creative financing solutions to turn your capital expenditure into an operating expense anyway. Mm-hmm. So, Dell and obviously most of the other OEMs and hardware vendors can offer these solutions as an OpEx model. So yeah. It shouldn't make any material difference whether it's in the hyperscaler cloud that you can only get an OpEx type transaction.
Yeah.
It's about being creative.
Well, Tony, let's dive into some specific technologies and talk about how those may be implemented. We know 5G is just starting to arrive in South Africa. In fact, it's pretty new everywhere in the world. Spectrum is going to be assigned hopefully by the end of this year, and we'll see proper rollout of commercial 5G networks happening in earnest starting from early next year. But how do you see 5G specifically as a technology impacting edge computing?
Well, it's actually going to definitely be able to support new initiatives, things like smart factories, smart hospitals, to be able to centrally manage some of these new opportunities. If you take smart cities, for instance, 5G is definitely going to provide additional foundations around being able to support these technologies. So I would say it's one of the enabling technologies, similarly to AI and machine learning, yeah. SD-WAN. There's so many different technologies that advances in compute with GPUs. 5G is just one of the networking or wide area networking components that support this edge type transacting.
I know you wanted to talk specifically about SD-WAN or software-defined wide area networking. Firstly, what is an SD-WAN? And why is it important in the context of this discussion?
So the SD stands for software-defined. We've had software-defined storage, software-defined networks is just the next element of it. And this is a specific application or set of applications that are software-defined for wide area networking. Where it really benefits customers is, in the event of how one's WAN is typically or currently configured, you've got very expensive MPLS type networks, but then you've got much lower cost cellular type networks. But it's quite a big shift to move from one to the other. And SD-WAN provides that overlay in between the two networks and allows you to determine whether traffic should be routed via the traditional MPLS network or to route it via the more cost-effective a cellular network. So it looks at least cost routing. It will look at load balancing. It will look at which network has the lowest latency. So you're quite flexible. It provides the flexibility to do those things, obviously, and ultimately to bring down cost in the long run.
Absolutely. Now, you mentioned AI, artificial intelligence, and ML, machine learning, allied technologies and concepts. We're still, again, in like 5G, it's very much in the early days of these technologies, probably more so than 5G. What role do you see these playing in enterprises going forward? And are these something that are going to be deployed? Are these technologies, rather, that are going to be deployed at the edge? Is there enough processing power at the edge, or is this something that's really going to sit in those hyperscale data centers?
So a couple of things. So AI has been around for probably since the inception of IT. So it's actually not new. Some of the advances like machine learning and deep learning are obviously newer and more relevant today. But AI is really just taking what used to be done by humans and allowing machines to do some of that. But it's been extended now just from doing the physical tasks to doing some of the thinking tasks that humans do.
Yeah.
So AI has been around for a while, and the location of where it's best suited, whether it's in the data center or core, or if it's at the edge, in fact, both have got use cases. So there's absolutely no difference as to where one is more beneficial than the other. But when we were referring to the edge and the specific workloads that are best suited for the edge for having real-time responses, there's a definite need for AI and machine learning and deep learning to exist in that location as well. So absolutely massive requirement.
So again,
those have all been,
Sorry, Tony, I was just saying, so again, it depends on the application. If you need something with extremely low latency, you're going to want to do this at the edge.
Yeah, if you need something in real time, you'll do it on the edge. And the AI component is really about quickly making a decision. But these type of things were not, the amount of compute that was available historically to support some of the new ML and deep learning applications just didn't exist. Or if it did exist, it was just too expensive. With advances in CPUs, with GPUs, high-speed memory, much faster disks, for instance, all of those technologies have allowed AI and machine learning to evolve. And it's probably one of the fastest growing IT technologies out there at the moment is the growth in that area of IT.
Yeah, interesting stuff. Deep learning is not something I've looked into much at all. But I understand this is having computers solve problems that are simple for humans but complex for machines. Just expand on that a little bit.
I guess a way to explain it would be, for us, if we had to try and determine out of a set of pictures, of those hundreds of pictures, which one is a cat? We'd be able to determine that quite easily. But try and get a computer to know what is a cat versus a dog versus a rabbit or a human. It's how do you get the computer to do that? And that is what deep learning is about. It's about providing, that you need to obviously do a huge amount of ingestion of data. You need to do a huge amount of training of the machines to get it to understand what are the characteristics to look out for to ultimately make the decision of whether it is a cat versus any of those other beings. And that's another point I would like to just raise at the moment. You're asking about, what are other applications and when do you put them at the edge? And AI and machine learning is one of the applications that you'll put out at the edge in many instances. And there's a lot of discussion, often get into discussions with customers saying, well, we'll put everything into the cloud or into our data center as a first place to test the functionality of AI and machine learning to see if it's something that we can derive benefits. But the reality is that the amount of data that needs to actually be processed and actually fed into this machine learning process requires it's significant. So the best place in most cases is actually to have those AI machine learning elements for the testing phase to actually happen at the edge as well. So it's just one of those things where everyone thinks, oh, it's easier to do everything in the cloud, we can just start it up, but everyone forgets about the amount of data you need to actually use to train the machines.
Mm-hmm. Tony, before I let you go, you're obviously having conversations every day with your clients on these topics. What is some of the feedback? What is some of the feedback you're getting from corporate South Africa on discussions about edge computing versus cloud, if I can call it that?
Well, I think for most customers, cloud is obviously the one that's top of mind for everyone at the moment. But emerging technologies like the edge and that are becoming more and more relevant for our customers. I don't think there's a single industry, as I mentioned just now, that's not affected or doesn't have a need for the edge type computing. So we're getting into more and more conversations. Customers are still, in some cases, a little bit uncertain as to the benefits that they can derive. And it's not only about the savings, it's also about being able to be first to market with new go-to-market things. And that's where the edge really comes into play. So it's having those conversations at a business level as opposed to a technology level. In fact, most of the more successful edge and AI kind of solutions are not necessarily done with your traditional IT manager or IT director or CTO. A lot of that is actually with the lines of business, whether it be marketing or sales or manufacturing. Those are the ones that will, those individuals are the ones that will get the value quicker in terms of, and be able to help you derive value out of those solutions.
And those are the guys who ultimately should be driving digital transformation, probably not the IT office.
Correct. IT should be there to support and assist and deliver the technology to meet those requirements.
Excellent discussion. Tony Bartlett is Director of Data Center Compute at Dell Technologies South Africa. Thanks so much for sharing your insights with TechCentral today.
Thanks, Duncan. Thanks, everyone.